can send you some sounds if you like.
Yeah, that would be great.
Awful sounds, but
No. That's what I'm looking for. I need some awful intro.
This is a castle in the middle of Spain, Madrid, called Torija.
Mechanical birds.
In our very first episode, we learned that not all natural sounds are equal, and not all of them are pleasant. In today's episode, we'll talk about how not all mechanical sounds are equal, and not all of them are necessarily bad. As we move into the age of the future, we expect to see drones flying around our cities, dropping off packages, and just generally making our skies look like those of Coruscant from Star Wars. But what do these drones sound like? Are they good or bad? And what do they mean for the soundscapes of our cities? Hello, and welcome to The Rest is Just Noise, a podcast all about the science, beauty, and sound of our cities. I'm your host, Andrew Mitchell. I'm an acoustician and a soundscape researcher at University College London. And I'm joined by my colleagues.
Hi, I'm Francesco. I'm an architect and a soundscape researcher. And you must be...
I'm Tin. That's me, yes.
And that's it. Nothing else. Just Tin? You a soundscape... Nothing no expertise?
No
Okay.
expertise.
No expectation.
No expertise, and yet we're trusting him to edit the bloody thing.
So today, on The Rest of Just Noise, we're speaking with Antonio Torija-Martinez, a lecturer in acoustic engineering at the University of Salford, who does have some expertise.
He does.
About the noise of unmanned aerial vehicles, or drones. He'll take us through his recent research on whether we can design drones to sound pleasant, or at least less annoying, and how these drones impact urban soundscapes. And if you'll indulge us a little bit, I hope you enjoy some rambling off into our thoughts on how we measure and describe complex soundscapes. Enjoy.
Mechanical birds.
Rest is just noise. Antonio, thanks very much for joining us.
Thank you for having me.
Yeah, it's great. So we're going to go through a lot of stuff today. Primarily, I think we're going to focus on some of your work that you've been doing on drone noise in urban soundscapes, and particularly a paper that you've published recently.
Yes.
But before we get into that, let's start with the same question that we ask everybody who comes on, which is just what was your path coming into acoustics? What do you do now?
Yeah, so I did my studies in Spain, in the University of Granada, South Spain. So my degree was environmental engineering. So I wasn't interested in acoustics by then, but then I was offered the possibility to do a final year project in environmental acoustics. So I started doing that final year project, and I really enjoyed it because I realized how important noise is in our lives. You know, sound is everywhere, and also noise pollution is one of the most important issues in urban environments as well. So
Well,
plenty of people
repeat over and over, it's the second most.
we say that. We say that all the time. Yes,
Air quality, isn't it?
air pollution. Yes. So we are second after that. But I mean,
I'm happy with that.
But what's the third then? We need the bronze and we don't know.
It doesn't matter.
I think there are quite a lot of decisions driven by noise these days. I was talking to Francesco on our way here. We were talking about connecting acoustics with other disciplines, and if you think about drones or new urban mobility, everything is about zero carbon transportation. But before reaching that zero carbon transportation, you need to deal with the noise emitted by those vehicles. So it's key to actually do that acoustic research in order to enable that, in order to ensure the wider adoption of that zero carbon.
So you're starting with environmental engineering,
yes,
and did this environmental acoustics project. Where did you go from there? Did you sort of
Yeah.
realize then that you wanted to stay
Yeah.
in acoustics?
After I finished that, I was, I was thinking, specialize in environmental acoustics. So I applied. I got a grant from the Spanish government, and I did my PhD in environmental acoustics there in Granada. But then I was working on urban sound, basically developing models to predict noise in typical Mediterranean cities. And because of the complexity of those cities, I employed machine learning techniques for doing that.
So how are you? I'm particularly personally interested in this because it's very similar to what a lot of my research is focused on. There are a lot of different approaches that people take to predicting noise in cities, noise levels in cities. We take, let's look at traffic flows, and we've got models that go from traffic flows to noise output. Were you doing sort of that, or were you looking more at the internal patterns of the sound and trying to predict based off of that?
No, but by then, what we have was basically information about traffic in terms of number of vehicles per unit of time, distance from the source, speed, and all of that. And then we have the second part was kind of understanding the propagation in the typical type of streets in the Mediterranean city. So I was more focused on in the overall traffic rather than going to the detail. So not working on micro scale, so it was more macro scale predictions.
Cool. And so did you find anything sort of interesting in that? We were talking earlier, we got into this 1/f stuff, which I don't know that we have time to really explain all the background of that, but that's sort of talking about like the randomness in these time patterns. How random is it? How predictable is it?
Yeah, I mean, it's something interesting. We did some work kind of, because I guess the general idea everyone has, that you guys work on that, is we need to go beyond dBs.
Yeah.
So dBs is giving you kind of very important information, of course, it's loudness, so you need to deal with that. But there's something else to understand how people perceive a soundscape. So there are a few things to take into account. Basically, going to take, but it's the spectral composition of the sound, but also the temporal composition. So with that 1/f metric, you cannot assume that if you kind of approximate a soundscape to that 1/f, tends to be more pleasant, more more preferable to be there to listen to that.
And that's because this 1/f is again kind of characterizing the relative amount of randomness or predictability in the patterns in the time patterns of the sound. And the theory is this exact 1/f, which is 1 over frequency, right? It's a decrease in the power as you go up with frequency.
Yeah.
That particular pattern is supposed to be the ideal for pleasantness or the perception in general.
Yeah, that's the theory. I think we were discussing this before. I think we are missing some further research trying to further refine that relationship between that 1/f with actual perception. I think there's some research to be done, to be honest, to kind of refine that relationship. I don't know, potentially optimize that. Who knows? But yeah, I mean, it's temporal structure of the sound is certainly something important. So I guess once you deal with the loudness, you need to focus on these other sound quality or psychoacoustic features, and certainly having that in mind, having that temporal structure might help us to understand how people perceive soundscapes. I mean, considering how you know better than I do how complex soundscapes are. So basically, it's so difficult to kind of reduce to kind of single metrics. But I think temporal structure is something.
I think that's a thing that has been quite neglected. is a lot of these things when we're looking at annoyance to single sounds or to complex sounds, they focus initially on the level, on the loudness, which is fine. That's the first order effect. That's the biggest thing. But then they move on to spectral composition, frequency components, tonality, that sort of stuff, which again kind of makes sense. But I think I came at it from almost like a musician's perspective of we've got three big primary things in music, right? You've got the rhythm, melody, and harmony, and leaving out the temporal aspect of complex sounds misses out the rhythm portion of that, right? And so it's been the struggle to bring that in, particularly for complex sounds, because that's where it really all kind of comes together into a cohesive thing, is how they line up in time.
I mean, it's not my expertise, but I really agree with you in this, because, okay, let's change the perspective. It's not just, or shouldn't be just assess the soundscape.
Yeah.
We should go to design the soundscape. And if you want to design that soundscape, you kind of need that approach, to take into account these three features. And, there is the rhythm is what is important to take into account. Absolutely. I mean, I guess we will discuss that later, but we are in this opportunity where everything is changing. I think the urban soundscape is going to change, with the transition of from diesel cars to more electric. So everything is going to change. So I think we have this opportunity to innovate and actually change the things. So change the perspectives and do something different. And I think that being more proactive and design rather than basically control or assess is something we should go for.
Yeah, I think that. So we've taken a little.
We need the drone thing to take off a bit.
We've taken a little diversion into something I personally really like, and I hope listeners can indulge me on that. But let's come into what we actually intended to talk about, which is this work that you've done on drone noise. Mm-hmm. So what's the sort of initial driving thing? What are the reasons to look at drone noise? Why should we want drones to start being introduced in cities? Why is it an important thing to look at?
Yeah, I think, again, considering the development of autonomous technologies, going for more hybrid electric, more electric transportation, I think the first step would be the introduction of drones. I think that's certainly going to happen. It's already happening. And if you listen to the sound of a drone, we were talking about that before, it's quite a nasty sound. Mm-hmm. The problem is potentially they could be quite a lot flying around cities. They could be quite a lot flying in rural areas as well, delivering medicine on, providing some useful service, but still flying around very quiet areas. So you have an unconventional source with producing quite an unpleasant sound. You'll have plenty of those. You'll have things flying closer to people than conventional aircraft. So all of this creates this potentially this massive problem of kind of people not willing to be exposed to that, potentially put it at risk that technology, that sector. If we are proactive and we say, okay, let's enable that sector because it's bringing economical, societal benefits, for example, delivering things, medicines, environmental.
Yeah.
So you are moving delivery parcels from transportation on the ground, reducing congestion, to have it that on the air. But you need to be proactive and you need to deal with that problem. So you need to deal with the noise in order to enable that sector to expand. Yeah. I think that was my main motivation, to be honest.
Yeah. Otherwise, we are changing number 1 and 2. I mean, air pollution with noise pollution.
Making more important.
The most important.
Yeah.
What sort? So in this work and in this sort of context that you're talking about, what sort of drones are we talking about? Because we can go from obviously
a toy,
massive military drones, all that, down to a thing that's about 6 inches across.
Yeah.
So what sort of scale are we talking about?
Yeah, I think What we are focusing on at the moment is small to mid-size drones. So I would say from 5 kilos to probably 100 kilos.
Mm-hmm.
That's our target at the moment. Of course, there are different features involved in if you go to the small end or to the large end, because something to take into account in drones, which is another complication, is if you look at an aircraft, it's quite stable. The sound is it's quite fixed. So you have an aircraft flying at a given altitude, not very much influenced by the environment.
You get the Doppler effect coming past, and that's about it.
That's it.
Yeah.
If you have a drone, apart from the sound produced by the drone, you have all the effects of the weather conditions. So the drone is moving around, and you have this kind of extra tones generated. So you have more interaction between tones. You have beating effects.
Mm-hmm.
It creates a highly complex problem for predicting the perception or assessing the perception, but also for predicting the actual sound of the drone. If you go to the larger end, you have more stable drones, so you have a more stable signal you can work on. But at the moment, we are focusing on that. The idea in the future is when we go to bigger vehicles, probably creating even a more problematic scenario. Use all the information we gather with these small drones to be applied to these larger vehicles.
So let's go right into the experiment that you guys designed to sort of look at that. So we're talking about these sort of small to mid-scale drones, sort of this sort of thing that you see like a YouTuber use to capture a video, something like that, right? About that size. So we're talking about looking at those as they're used in cities, the way that places like Amazon are talking about using them for delivery.
Mm-hmm.
So talk us through a bit of the experiment that you guys designed to help us assess how that will impact people's perception of urban environments. What sort of questions were you trying to work out?
We're kind of focusing on two things. So the first thing we are focusing on, that's the paper we published, is the actual design of the vehicle. So how do you design the drone so it creates a less irritating sound? So you need to basically work out, for example, I don't know, how quickly the rotors spin, what is the spacing between, because a drone would be composed of multiple rotors. So what is the spacing between the rotors? Because that's a quite important factor as well. So you need to deal with those physical magnitude, these physical parameters. And the idea we are doing is kind of connecting sound quality metrics or psychoacoustic metrics with that physical parameters in the design. Mm-hmm. So that's the idea with the objective of embedding human perception into the actual design of the drone. So you are solving the problem early in the process. Once you have the drone operating, that's a second problem, and then you need to actually kind of doing something similar like you guys doing. You need to generate a realistic soundscape of a drone flying around. A given, you can simulate different maneuvers, you can simulate different altitudes, different velocities, and that. So what we tend to do, or what we are hoping to do, is simulate these realistic scenarios with a drone embedded in a given soundscape, and basically using 3D audio, virtual reality, enable these realistic simulations, so we can have a quite accurate representation of how that drone might be perceived by people exposed.
So I think actually we may have to cut back. I don't think I communicated this very well. I don't think that's the paper that I read. So the one I went through was effects of a hovering unmanned aerial vehicle on urban soundscapes perception, which was not about the design, was it? Or did I misunderstand it?
No, it's about. I'm sorry, that's another. That's
what I mean.
No, that's another one. That's another one. No, that's fine. No, that's.
Sorry, we can talk about. We can go into either one.
No, I mean,
no, that's the first. Yeah. That's a paper we published last year, I think. Yeah, that's about the operation of the drone.
Yeah, we can go.
So that's where I was planning to go, but we can certainly go right on back to the design.
I wanted to follow up on the one about design. So I mean, how could can it actually get? I mean, can it actually become not annoying at all?
No, I wouldn't say not annoying at all. I would say
You have to suffer a little. I mean,
If you
No, I mean-
order for Amazon,
No, but-
suffer.
suffer a bit.
for example, we did this experiment. I was referring to another paper
Oh, no,
published in JASA for the design. And in that one, we did this experiment where basically we were moving apart. So there was this contra-rotating system, so two rotors rotating at different directions, and that's something used in some drones. And what we found is, apart from this, the character of the sound changing quite a lot when you move apart the rotors, just the decrease in loudness is massive. So you can have a decrease of, I don't know, like, I can't remember now, but I think it was like 12, even more dBs. So it
So
matters.
what causes that? What physical thing is causing that? If
Yeah.
it's the same rotors at the same
Yeah.
speed and just moving them
So
apart.
basically, when you have two rotors rotating in different directions, what you have is potential field interactions between them. That's essentially creating tones, an amplification of tones and certain harmonics. So it's quite apparent. When you look at the frequency spectra, you see those interaction tones. When you move those apart, you see a significant decrease in that.
That's amazing. You could play a tune.
Yeah, actually. But if you move even farther, you will start having a creation of more broadband noise because of all the turbulence you create. So it's actually an actual
Range.
optimal spacing between the rotors, just to have a.
So this is how you make it pleasant.
Yeah, it's kind.
You make them you make it play a song as it's flying
Yeah,
around.
I wouldn't say pleasant sound. I can share some sounds with you.
Come on, you're the
can tell me-
ambassador. You have
Take
the,
a
you have
Jordan
to
Lacey
advocate.
approach and turn the noise into music by making it play something.
Well, might be the future.
No, I mean, it's just like Anschütze Neubauten or that,
Yeah.
industrial sound.
So when you're looking at that, you just mentioned, you get a 12 dB difference in what other sort of perceptual metrics were you looking at, or psychoacoustic metrics?
Yeah,
were you
so
looking
we look at everything. We look at loudness, sharpness, fluctuation strength, and roughness and tonality, and also impulsiveness. So basically, what we found is if you, at the optimal spacing, you have a significant drop in loudness, a significant drop in tonality as well, and also in fluctuation strength. So you have this beating effect between the rotors is significantly decreased. If you start moving that apart and you go beyond that optimal spacing, you start having an increase in impulsiveness, in roughness, because you have all this turbulence.
Sure.
So again, it's quite important to focus on these sound quality metrics to actually design a.
That sounds amazing. Do you have any feedback from the industry on that?
Not from industry at the moment. We are working in a project with some industry partners, and we are hoping to present that to them and continue that research. What we did was continue our research, and we just completed a listening experiment with participants reporting, because the first paper was only implementing psychoacoustic and audio models, Schweikes model, and now we are actually, presenting those sounds to people. So we are about to submit that paper, hopefully
Cool. Fingers
soon.
crossed. No, but I mean, just saying every drone could be 12 dBs quieter, that's a massive thing.
Well, the counter-rotating.
Sure,
Yeah,
but
yeah.
like,
Not-
that's like saying every
No,
drone
no,
should be
the-
counter-rotating, right?
No, not everyone. I mean,
No?
but again, you will have other factors to take into account. So the key idea is to have, if you have kind of general rules or kind of general models dealing with, considering all these psychoacoustic features, you can basically apply that to whatever design you want, because there will be certain things you want to avoid. And you can basically explore the design space of these things, looking at that subjective model.
And the benefit you've got compared to a lot of what we discussed in sort of more complex urban soundscapes is those psychoacoustic metrics and the annoyance metrics were designed for exactly that sort of sound. They were designed for like the single product sounds.
Yeah.
And we kind of, over in our world here, we corrupt them into dealing with more complex stuff.
Yeah, I mean, I would say it's more difficult if you want to apply those metrics in Soundscape. It's kind of more difficult because you might have kind of a preliminary stage, kind of linking that to sources, kind of like that. It's a little bit more complex because you have, a soundscape is quite a lot of things happening at the same time. So it's quite difficult to find correlations. But I guess if you go to sources first and you kind of correlate that, that's a very useful tool.
So real quick, going actually back to the counter rotating, is there any link there between decreasing those sort of turbulence effects to decrease the loudness and improving the energy efficiency, the power efficiency of the drone? Because I've always thought of, particularly in product design, like the noise that it's producing is part of an indicator of how efficient it's operating.
Absolutely.
Because it's wasted energy.
Absolutely. It's not, it
feels like a co-benefit.
Absolutely. It's not like that all the time because you might have some trade-offs, of course. But for that particular paper, my colleague, Dr. Chaitanya Parachuri in Southampton, he did his basically more focused on the acoustics, aerodynamics, and he did that assessment as well. And he found exactly at the same axial distance between rotors increase in the performance of the system. So absolutely, there's a quite clear relationship most of the time between less noise, more efficient. So it's good for us when we try to embed
the tense thing about the industry feedback. Like you're basically telling them,
saving money.
A way to decide the most efficient way design thing is how much noise is it producing.
Absolutely,
that's a very good sort of. Oh God, I was about to say synergy, and then I hated myself. But it's this good co-benefit between the two.
Yeah.
Yeah, Antonio, can I jump in for a question? Because I was thinking about, the regulatory framework in general for these new sources, right? So in general, for the operations of drones, we went basically from no regulation to now operations being strictly regulated. You need a license as an operator, as a pilot, and things like that. But is there anything related to noise into regulations in terms of either emissions or, this kind of stuff?
So, as far as I understand, there is only one single European regulation from, I think, 2019, I think. And it was purely for small drones and only focused on sound power.
Okay.
So basically, you have this relationship between the mass of the drone and the sound power allowed for that drone. The problem is, again, it is basically that regulation is built upon, other appliances, home appliances.
Yes.
So I don't think it's quite applicable to drones because at the same, you just basically taking a drone to a semi-anechoic chamber and basically measuring sound power, but the operation of that drone will be highly affected, as we discussed before, by weather. So
sound power feels like a strange thing to use for drones because I think if I remember correctly, you also said a thing that like there's a limit where they can't operate within 50 meters of people. Well, if you're at 50 meters versus 100 meters,
absolutely,
the sound pressure level that you experience is a massive difference. Yeah. So sound power in that doesn't really make that much sense. It makes sense in an appliance that you have in your home, where you're always going to be about the same distance from it.
And basically, the sound that appliance is going to produce is kind of similar to the test you are doing.
Yeah,
with a drone is different. I guess in aviation sector, so for an aircraft, before you need to get the certification, and you can have a quite structured procedure. So basically, you measure the takeoff and measure the landing. So basically, you measure at 2 points during takeoff, 1 point during landing. I guess there should be something like that in the future. Okay. So kind of a protocol for certification, something more standardized. As far as I understand, there's not such a thing at the moment, but hopefully there will be something like that.
But this is from the source point of view, like emission and power. Yeah. So I mean, imagining there will be hundreds of those flying around in a relatively near future, will we get to the point where we have, I don't know, noise maps for drones as a source? Would it make sense? Will we get to the point where we'll have WHO recommending LDEMs?
Another song.
Corridors,
I don't know if they will include that as part of the aviation, to be honest. I don't know. The other thing is, when we think about drones operating in a urban environment, I don't think there will be kind of drones everywhere like crazy
Like cars.
city. No, I think it's going to be kind of similar to an airport when you have routes, for takeoff
Corridors.
or
So
landing.
there will be corridors for drones.
I'm assuming there will
probably.
be corridors for drones. So,
But then we
basically-
will have noise maps for the corridors then, probably.
Yeah.
probably you will need to.
Yeah.
I mean, the same way you produce
For
noise
the
maps
airports.
For roads.
for
traffic
helicopters and
noise,
something
yeah.
like that. You might need to do something like that.
I mean, that was one of the points I wanted to get at of the paper that I did read,
yeah. So
which to summarize it, you basically found that it would be very useful to have those sorts of corridors because the drone noise can be masked by the traffic noise, right, and be less impactful. But one of the justifications that's sort of given for that is we can improve over diesel truck transport for delivery by having electric drones.
yeah.
But those drones you found or cited a previous study which found that they have about a 5 dB penalty in annoyance, right?
Yeah.
So a drone noise which is 5 dB less than the traffic noise has about the same annoyance rating, right?
Yeah.
So aren't we then replacing diesel trucks which can carry hundreds of packages with now potentially hundreds of drones which
Yeah.
each carry a 5 dB penalty?
And one package.
Yeah,
And
one
one
package.
package.
Yeah, I mean, this. Yeah, you're absolutely right there. I mean, it's not the. Sometimes in academia we tend to work in the hypothetical,
Yeah.
theoretical case. I think if you have drones flying around, and again depending on the number, because that paper doesn't just consider one single drone operating. So
And
you
quite
have
close as well, I think.
and
I
quite
think it was
close,
a couple
yeah.
meters, wasn't it?
So if you have, quite a lot of drones, I mean, I guess you will need to have some sort of regulation to say, okay, you can operate up to this.
Yeah.
What we found there is that if you have drones flying around along these corridors, it's probably more efficient to have the drones flying around, highway or something like that, or, considering all the complications,
Risks.
but a risk, a highway rather than a public quiet space, because the impact would be much less.
Yeah.
Going back to the electric cars, so if you have a transition to more electric cars, you will essentially get rid of the engine noise. You still have the rolling noise, aerodynamic noise,
Yeah.
and that. So you can have still the masking, but again, it depends on the numbers.
Yeah, for me, the argument just doesn't seem to hold because if we were to move to electric cars, which I think, like, particularly for that sort of like truck transport stuff, at least within like the urban core, we're gonna get to that. Then it seems like from a noise perspective, the drones only have that masking really at highway speeds, right? When we have the rolling noise. So the highway, but are drones really that useful for deliveries for highways, or are they more of a last mile thing?
There will be last mile things. Yeah, I mean, it's again, it's more research to be done to find the right numbers. I guess again, there will be last mile. Probably, I don't know. Probably there won't be a significant problem in cities. There will be more problems in other environments outside cities when you have, quiet environments. I mean, it's not again, it's potentially more research to be done once we have, because the problem we have so far is we know drones are operating, but they are basically some pilot studies. So you have, in Reading or some places in the UK, in Scotland, you have a trial now.
Mm-hmm.
There are not so many places. So the first thing you need to understand is what is the magnitude of the problem, how many drones are flying, and then you can basically do that analysis. I agree with you. I mean, I wouldn't say that the main, there would be an overall benefit of transitioning for, ground transportation for delivery to drones. I'm just focusing. If that happened, what might be the implications for noise, and what can we do for that?
Yeah, I think to me it seems like the framing should be less of this provides any sort of real benefit to environmental
I think they are.
quality or climate change, because the better option is electric trucks or electric cars, and it should be more of like a warning of if places like Amazon are moving towards these sorts of drones, we're going to have some noise problems that would be solved by other methods.
Yeah, I think there are some papers actually kind of doing this research, trying to understand what are the benefits from, energy consumption of that if you go from traditional transportation, even in considering electric cars to drones. There are some benefits in terms of actual emission and basically energy consumption, which is money. And I think that's, as usual, the driving force there. If there is a transition to drones to deliver parcel, is because they are cheaper to operate for the companies. Then we have the other end of people exposed to that, and whether they are willing to accept that or not, and what can we do in order to solve that problem.
Which I certainly think, similar to some of the stuff we have in wind turbines, that if people are getting a benefit from them, they'll deal with more noise. If the drone is delivering to your house,
you don't care.
You're probably not that bothered by the noise.
Yeah, that's
but
the thing.
But if it's delivering to your neighbor's house,
and
every day, you're going to be a bit pissed.
Yeah, and the other thing, I guess, is going to the non-acoustic factors.
Yep.
I guess it depends. If you are just, I don't know, if you're in the countryside and your neighbor is receiving a parcel and that it's important, or this is a hospital, and in Southampton there's this trial moving from Isle of Wight Hospital to General Hospital in Southampton. So you are more you okay. You are happy. Okay, it's noise, but it's something important. If you have your neighbor ordering a coffee or something, it's like
on that, a very interesting thing I saw a couple of years ago, which I'm kind of talking from pure memory now, was a video about some African communities that were using drones to deliver blood to further away communities and other medical supplies, because there's just no other way to get there, but they could just immediately get it from the hospital out to them, and it saves lives. And that, here in London, we've got the motorcycle drivers, the scooter drivers that all have blood delivery on the back of it. Replacing that with drones, 100%.
Yeah, absolutely.
That seems like a fantastic benefit.
Yeah, absolutely. I think that, again, is the use of the drones.
Yeah.
What is important there, I think, of course.
My association with drones is always, for some reason, Star Wars Episode 2, Coruscant, so everything is in the air, all traffic.
Yeah.
And then there's the assassin drone coming to assassinate Amidala.
It flies through, goes up to the window, cuts a hole in the window.
Yeah. And they're sleeping and they don't notice. So where's the drone noise there?
Yeah.
Right?
Oh, well, they've got repulsor lifts. Come on. They've solved the counter rotating.
Sort it out then.
So that's what's coming next, right? To solve the noise problem, you're going to invent repulsor lifts.
Well, our research is only, civil drones. We understand.
Well,
we understand
tell
that
us about is the civil drones.
we understand that
Disclaimer.
they will be. I'm sure there are quite a lot of technologies already tested or to be tested to make these things very, very quiet. Other purposes.
You may well think so. I couldn't possibly comment.
Yeah.
On that happy note.
Yeah.
Tin, Francesco, any other things?
I think we covered a lot of ground, and
we didn't get to Spinal Tap.
No.
And the 11 scale.
11 scale.
11-point scale.
It only goes anyway.
But
Antonio, thanks so much for joining us and talking to us about drones and rambling with me about temporal structure. Is there anything else that you're working on right now coming up, or that you'd like to sort of plug and let people know about? Well,
now it's basically all aviation. So basically within this idea of perception influence engineering, so embedding human response to the design of new aerial vehicles. So basically we are focusing on drones, and also we are part of another project, Inception, where funded by Innovate UK, where we are modeling and trying to advise to solve problems of an all-electric propulsion system. In the future, we will do probably a little bit more research on the area of road traffic and soundscape, but I can't say much at this moment, I'm afraid.
And I know, this might be going out after the call will have closed, but I think you're hiring right now, aren't you?
Yes, I'm hiring for a postdoc to work on the drone noise project. So yeah, please apply.
If anyone would like to apply,
yeah,
I think we've got some potential postdocs in our audience somewhere.
Yeah, so
great, yeah. So how can people follow what you're doing or get in touch with you? What's the best way?
So I guess the easiest way, that advert is posted in our social media, Salford Acoustics on Twitter. My Twitter handle is at AJ Torija, Torija. So you can follow me on Twitter.
All right. Cool. We'll put all those links down in the description.
Yeah, I'm happy to share that with you guys.
All right. Thanks very much, Antonio.
Thank you very much, Antonio.
Thank you for the invitation and the opportunity to talk about my research. Thank you very much.
Brilliant.
Thank you.
And cut.
So just now I remember.
The rest is just noise.
You can find episodes of The Rest is Just Noise on all of your usual podcast apps.
And on our website at justnoisepod.com. We're also on Twitter as @justnoisepod.
The Rest is Just Noise is supported by the UK Acoustics Network.